Okay, so this next video is basically twofold. We're looking at multimeters and how you use them, and we're looking at voltage sources. So I have a solar panel, I have a AA battery pack. If you click on it, you can change the cells from 1 all the way to 4. You can add a switch, or you could not have a switch. You can change it from AA to double or AAA. So we will start off with one battery. So the other thing that I'm going to show you is this thing called a multimeter. So if you scroll down, as part of the instrument panel, you have power supplies, function generators, oscilloscopes, and of course multimeters. And so it's just as simple as dragging one out. You could copy it or you can delete it. You can set it for 3 different things. So we can do amperage, which is basically the power measurement, but not really. The resistance, which would be the ability to slow the flow, I guess. So to reduce the amount that's going through it at a specific time. And we're going to deal with voltage. So you can think of it as basically the water pressure. So the difference between having electrons kind of drip through the circuit, which would be low voltage, and having them shoot through the circuit, which would be high voltage. Okay, so the first thing we're going to do is just move them and click on the object. Now this one was reversed. If you hit this right here, this was the original state of that 9-volt battery, and it was negative on the left and positive on, negative on the right and positive on the left. But you can reverse it using this. So you select the object and then you can move it, and that way it works very easily. This is a lemon and a potato, and when I hit simulate, we've got all the different sources of voltage. So now a solar panel is limited by what type of energy it's interacting with. So if on a bright day, it's going to have a high voltage, and then on a cloudy day or at night, it's going to have low voltage, and then it's probably going to be somewhere in between. So if the panel is dirty, it's going to get less, and if the panel is clean, it's going to get more. And then also the angle that it's facing. So you can sort of see as I drag it, it goes from 0 to 5. And you could put solar panels in a series. This is only an example. I'm pretty sure panels are not always like that. With this, it's a 9-volt battery, so you expect it to have 9 volts. Now, in truth, it's varying degrees of charge state, right? There's a chemical inside a 9-volt battery and a AA battery, and it depends on what level it's been used up. So sometimes it'll be over 9 volts, like 9.5 volts, and sometimes it'll be considerably less than 9 volts. So if you're using a 9-volt battery in a circuit, typically if you measure the voltage with a multimeter and it is less than 9 volts, you probably should start thinking about changing it out. And if it's at 7 volts, you should definitely change it out. With this one, every cell in a battery is 1.5 volts. So if you were to take 9 volts and you were to sort of count up, you could determine how many cells actually are in a 9-volt battery. And if you've ever taken one apart, you can see that it has quite a few. So if you think of, let's click on this battery. So let's go to 2 cells. That would be 3 volts. And 3 cells would be 4.5 volts, and 4.5 volts is half of 9. So we know that this 9-volt battery will actually have 6 cells in it, and we can only go up to 4 cells in this battery pack, and you can sort of see how it goes up accordingly. So if you're going to run something that is sensitive to 5 volts, like a typical logic circuit, you're going to have to be very careful that you don't go over the voltage. So maybe keeping it to 3 cells, or sometimes your circuit's robust enough that it can handle 6 volts. Okay, so this is a coin battery. We'll zoom in on that. So that is very common. Now this dimension here is an indication of how thick it is versus how what is the diameter versus the thickness. So every battery that you use for a watch or whatnot will have basically a dimension, and then it'll also have a voltage on it. So if I click on it, it doesn't really give you much to choose or to change. And then the last thing that I guess we're going to talk about before we get into hooking these together is a potato. So what does the M mean instead in front of the voltage? And that has got to do with millivolts. So you can think of this as 670 millivolts, which is about actually it says right here, 0.67 of a volt. So basically you're dividing by 1,000. Does that make sense? And then for the lemon, it's going to be slightly less, and it's going to be 0.52, so basically half a volt. Okay, so now if we stop the simulation, then we can start modifying things. So we'll just get rid of the things that we're not going to play with. And we're going to do something called series and parallel. So if I was going to take this potato, and I can control copy it, or I can just drag more of them out. And let's say that I was going to hook some potatoes in series. So we'll zoom in on it. So to do that, we could grab a wire, and we could go from black to red, red to black. And then from here, we can hook it up to the multimeter. And so now when we simulate, what do you think it's going to be? I think it was like 0.6, so when we hit it, it's going to be almost 2. Actually, it's going to be 2. So that is called a series circuit, and that is how we get voltages to increase. And that is what's actually happening in a 9-volt battery. So what could we do next? We could do the lemon one. Let's stop the simulation. Maybe let's do the coin one. So if I break this circuit here, and I start control copying and control pasting them, and join them together. Now if you look on YouTube, there's some videos where they take this to the extreme. So each one of these cells is 3 volts. So if we count 1, 2, 3, 4, 5, 6, what would 6 times 3 be? And so we hit start, and it's 18 volts is what you would think. So what I want from you is I want you to play around with the multimeter. We always want to use the voltage setting, so make sure it's in the voltage setting. And you can make a bunch of series circuits and see if it changes the volts. Now, if I wanted to just sort of mention parallel, so let's say we're going to make a parallel circuit. So parallel would be all the reds hooked together. Now, when you're actually doing your wiring, I haven't really highlighted how to do this. Every time you click, it gives you a joint, and it's easy to find the point if you're coming. It's got a highlight to that red color. Okay, and then to move a joint, you just click on it, and to triple click, you can add a point. So you can make your wiring look good. And we'll just do this. One is for the black color, and we can go around. It's hard to start a point that already has a wire on it, so it's always a good practice to start on a point that doesn't have a wire on it. And it's a little bit easier to do it this way, where you wait till it highlights and then it works. And then what is your guess? Is it going to change the voltage? So when we hit simulate, we've got 3 potatoes and we had 2 volts, and these were about half a volt each. So when I hit simulate, is it change? So it's exactly the same, because this is a parallel circuit and this is a series circuit. So I only want you to show me series circuits so that we can see the change in voltage. So what I want you to do is basically do the same thing that I did, but then I want you to choose one or two of them to make a series circuit that has a higher voltage. Okay, so good luck and have fun with that.